Welcome to another topic of SU Studies with you. Today we'll be covering the topic of decimals. How to add, how to subtract, how to multiply, and how to divide anything that entails with decimals. Many times we're afraid of decimals, guys, but it's nothing more than a fraction. Fractions can be converted to decimals, decimals can be converted to fractions. So let's put an example of each, guys, and hopefully this will help us better comprehend this topic, guys, and be better prepared in math for whenever we need it in life, guys. So let's start off by, what do we do if we have to add 4.7 or 4 7/10? We need to add it with 1 and 5/100, and we need to add it with the whole number 7. So we have three numbers here. They're not aligned. So your teacher, yes, I know, threw you a curveball, but what do you do to actually answer correctly? Align them up, guys. Each number has a place value. The numbers to the left of the decimal are whole numbers. The numbers to the right side of the decimal would be considered your decimals. So we could start off by putting 4 7/10. And we could put underneath the 1 and 5/100, and we could put the 7 where? Underneath the 1. Why? Because it's a whole number, guys. It's not a decimal. Some students will fall in the trick of saying, I'm gonna put it underneath the 0. It doesn't say 0.7, guys. It's 7 whole numbers. Now the numbers are aligned. See it or not, the decimal is right there, invisible. If you want to, preference, you want to waste my marker? Not just kidding. You can put as many zeros as you need to. You don't have to, but that helps you align and it looks like a nice block style. It's nothing more than you add your answers. 5 by itself, 7 by itself, 7 and 4, 11, plus 1, 12. What do we do with the decimal? Nothing more than bring it down. So 12.75, or you could even convert it to a fraction, which is nothing more than 12 3/4, or even a percent if you want to, but that's another topic. So that's one example of adding. Now let's look at what do we do when we have to subtract. So subtracting decimals, very similar, but let's look at the operation that we have to do for those numbers. Give me a second, guys. We're back. All right, guys, so now what do we do in case we need to subtract some decimal values? And let's go with a little bit larger number. So let's assume we have 102 with 358.07. That number is actually 102 and 35,807. Remember, tens, hundreds, thousands, 10,000s, 100,000. So you read the number 102 and 35,807, 100,000s. And let's assume you already aligned it up. We need to subtract from 81 and 0.490912. Yeah, it's a big number. Oh, we have to read it. It's 81 and 490,912. I'm pretty sure that's like 10 millions. Tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions. So again, the number would be 81 and 490,912, 10 millions. So the numbers are aligned. The decimals are aligned. Everything is in the right place values. 1 with 1s, 10s with 10s, and all of the decimals with their corresponding place value. Like, but we're missing 2 spaces there. Well, fill them up with 2 zeros, guys. Nothing wrong with that. What do we do now? We start subtracting by borrowing, guys. Nothing wrong with it. So we have to start from right to left. So this digit needs to borrow from the 0, but that 0 doesn't have any, so it starts from the 7. 7 drops to a 6 and gives 10 units, so might as well place it as a 9 because the last digit will become a 10. And we start subtracting now. 10 minus 2, 8. 9 minus 1, 8. 6 minus 9, not enough. So he borrows from the 0, which doesn't have any, borrows from the 8, drops to a 7. This becomes a 9, and that becomes the 10 units. So now it's 16. 16 minus 9, that would give us a 7. 9 minus 0, that would be a 9. 7 minus 9, oops, we have to borrow again from the 5, so that drops to 4 units, and that's 14. Why? There's no numbers in between. Nothing had to, there wasn't any middleman in between. So 17 minus 9, that would be 8. 4 minus 4, that would be 0. 3 minus 0. 0 minus 3 would be 3. what do we do with the decimal? Nothing more than bring it down. 2 minus 1, 1. We need to borrow, so the 1 drops to a 0. That becomes 10. 10 minus 8 would be 2. How do we read that number? So it's 21, and that looks like what? 3,089,788. What was it? 10 millionths. Cool. And that would be the answer, guys, for that number. If they want you to round your answer, might as well, like a heads up, a tip. Sometimes your problem would state round to the tens, round to the hundreds, round to the thousands. If they're asking you to round to the tens, you look to the number to the right of it. In this case, it's a 0. Doesn't help, so we could just say this number rounded to the tens is equal to 21.3 or 21 and 3/10. If the problem would have stated rounded to the hundreds, which is the second digit, in this case, your answer would be 21.31. Why? Because the 8 helps out the 0, and so on, guys. That's rounding. That's the pessimistic or optimistic. Do you see the glass full or almost empty? Sounds good? Awesome. Give me a second. So now we can look at examples. What do we do when we need to multiply or divide? Welcome back. So now we already learned how to add, how to subtract. Now let's look at what do we do when we need to multiply decimals. So really fast, let's put some numbers. So let's assume we have 4.708 that needs to be multiplied with 0.0000012. Woof. So a bunch of decimals. Yes, why not, guys? Don't be afraid of them. We have to do it. Oh, well. Does it have to be a line? No, not really. Who cares? The 12 could have been on top and the 4.708 thousandths on the bottom. It's up to you. Let's just do it this way. We just need to multiply digit at a time. So 2 times 8, 16. Why am I writing 16? There's a 0 down there, guys. Might as well bring down the 1. 2 times 7, 14. I'm not going to put 14. I have to carry my 1. 2 times 4, 8, plus 1, 9. So that's equal to 9,416. Next digit, 1. 1 times 8, 8 is the second digit. I have to scoot over a little bit to the left side every time we multiply a digit. 1 times 0, 0. 1 times 7, 7. 1 times 4, 4. Yes, it's exactly the same number. I hope you don't want to waste your pen and pencil and paper, guys, and start multiplying the zeros by all the other numbers. You don't have to, guys. We ended up here. So what do? We just add it up. 6 by itself, 6. 8 plus 1, 9. 4 by itself, 4. 7 plus 9, 16. Carry 1. 4 plus 1, 5. So that's pretty much the answer we need to multiply that we obtain. Now finally, how many decimals do we have in total? 3 on the top. 4, 5, 6, 7, 8, 9. So 9 in total. 6 on the bottom and 3 on the top. That gives us 9 decimal place values. So what are we going to do? We start from right to left and scoot over 9 times. So 3, 4, 5, 6, 7, 8, 9. You place your decimals and you fill up the gaps with zeros. So your right answer would be 56,496, 10 billions, 100 billions, I don't know. Let's look at the right place value. Tens, hundreds, thousands, 10,000s, 100,000s. And then we get the millions, 10 millions, 100 millions, billions. So the correct way to pronounce this number is 56,496 billions. Make sure you put the THS sound at the end. Awesome, guys. And then really fast, we're almost done. All right, let's do it here, guys. How do we divide? So let's already assume that we have the number. So I'll put 3 examples. 0.03 divided by 49.7. 0.03 divided by 6, just like that. And we have 3 divided by 0.12. Out of those 3 examples, which one is ready to divide? First one, second one, third one. Believe it or not, only the third option is ready to start dividing. Why? We don't want the number outside of the box to have a decimal place value. These ones do have it, except this one. In this example, it's ready to divide. All you do, you bring down your decimal and you start dividing. 3 into 12. It doesn't fit into 1, but it does go into 12. So our answer would be 0.04. In this dilemma, we need to get rid of the decimal. We have to move it twice. So guess what? The 6, we need to add 2 more zeros. So it's really 600. So now we're dividing 3 into 600, which would equal 200. And that would be that example. In this example, very similar, we need to move it over twice. The decimal's right there, so we move it over twice by adding a 0. And it's nothing more than to start dividing. 3 into 4 ones, remainder 1, bring down the 9, 3 into 19, 6, 18, remainder 1, 3 into 17, 5, which is 15, remainder 20, 6, 18, 20, 20. You could put a little bar on top indicating it goes on forever and ever, or you could put a decimal and it goes on forever, or you could write it like a fraction, which is 2/3. Awesome, guys. I hope to see you around soon where we can see more videos and get more tips and tricks of what happens with math. See you around soon, guys. Take care. Stay safe. Bye.